Hey all, welcome to my channel, Otherwise Ahoy. And at first I would like to say please consider subscribing. It is free. And you can later on subscribe also if you don't like my content. So in today's video we're going to sorry for that. We're going to do a little bit of prove things, yeah. We are going to prove things, and this is gonna be at first what is the proving. The proof is about the first definition of derivatives, yeah. The first definition of derivatives, as you know. Now at first this is the content we are having today, and in the next portion we are going to cover that d by dx of x to the power n is equals to, that is nx n minus 1, and this is what we are going to prove by now. So at first we have to prove that the first definition of derivative, of course. So at first we have to know what is derivative exactly, yeah. What is derivative exactly? So let's try to understand. At first what you have to do is, what is derivative? I would like to say that it's just a small change like delta y, yeah. Let me draw a graph first. This is a graph we're going to plot today, and let's say this is x distance, this is y distance, yeah. This is y distance. So this point is this point, yeah. This point, this is a very 1 minute, give me 1 minute, okay. This point is x comma y, yeah. Now what we're going to do, that we're going to have a very small growth which is del x, and here also very small growth which is del y, yeah. So what's called derivative exactly? That when del x tends to 0, limit is the sign we use for that, then the ratio of this to this is dy by dx is called. That's what, yeah, that's what derivative is. Now at first let's try to understand that there is a function thing. Yes, you of course have learned what is function. That if y is equal to fx, like let us consider that f is a machine where x enters and gives an output, yeah. And that's what a derivative theory is based on, yeah. This based on the theory of functions. That's why you have to read functions before you start derivatives, because we need functions in that, as you know, that if y is equal to fx, then it's possible, yeah. Then it's possible if y has any relation with this, of course. So let's move to the first definition of derivative. Now as we know that limit del x tends to 0, del x is very small, that's why we are using the term del x tends to 0, del y by del x, yeah. Del y by del x. Now how gonna represent it? As in the picture, that y is growth, y plus del y, and also x plus del x. As x is y is a function of x, let's just move on the function point. Y is equal to fx, then we know that the growth with respect to the x here is f x plus del x minus f of x, yeah. This is the growth of y, yeah. If we consider y is equal to fx, then now you can understand what's the importance of functions here, yeah. So now let's say that limit del x tends to 0, f of x plus del x minus f of x divided by x plus del x minus x. This is the growth, of course. The final point is, final length is this, and the initial length is this. So final length minus initial length is the growth. Here also the same thing is just shown, yeah. So at what we have to understand is that, okay. Now this is what the first definition of derivative is. If we just further improve the thing, x is cancelled out and consider del x as some term h. Yeah, so let's just substitute h in the place of del x, and this is what comes in the derivatives first definition. So this is what derivatives first definition is. Now using this first definition of a derivative, we will find what is d by dx of x to the power n. This is called the power. Yeah, this is n is the power and x is the base. Yeah, x is the base. As you know, in just you have learned exponents. Yeah, so what do we have to do? That limit here h tends to 0, as you know, and there the function is, that's a power function, exponential function, which is x plus h, and the function just to the power n minus x to the power n, as it's a power function, as it's an exponential function. Yeah, so I was stammering because sometimes I do have a problem like this, stammering. Sorry for that. Now this is h. Yeah, so now by the rule of binomial we can just expand this. Okay, let's expand this. Yeah, so by expanding this, what do we get? That x to the power n plus nc1 x to the power n minus 1, that's the rule. Okay, now h plus nc2 x to the power n minus 2, that's h square. As you've noticed that a plus b square is a square. Yeah, plus 2ab plus b square. So this is the common part, and this is the middle part is just arranged by Newton. Okay, was just arranged by Newton in this way. So let's not further discuss about this, because you must know binomial definition, binomial expansion. Yeah, so that's what. And now what we have to do is plus h to the power n, and there is also minus x to the power n. If you have noticed, go back in the video's first part, you will get it. Limit h tends to 0, and there is h. Just screenshot this, just screenshot it. I have a stammering problem. Yeah, so pronunciating is just means very difficult for me. Yeah, so x to the power n gets cancelled, and this is what is left. Now what are going to what we are going to do is let's go. What we're going to do is, just we have nc1 x to the power n minus 1 h plus nc2 x to the power n minus 2 h squared and there is plus h to the power n, and there is limit h tends to 0 by h. Now just take h in common. Yeah, h in common, so that's h in common, and that's at first there is nc1 x to the power n minus 1, and the h is just in common, so we don't need to write this. Okay, so plus nc2 x to the power n minus 2, and there is h h to the power n minus 1, as we have taken h as common, divided by h, so h gets cancelled, and that is left. So sorry for that. Limit h tends to 0, and there is nc1 x to the power n minus 1 plus 0, sorry, not in this step. Yeah, so nc2 x to the power n minus 2 h squared h to the power n minus 1, and in the next step, as it has, this is then, okay, as this has h, and the middle all the terms has just contain h, so they will be 0, because 0 multiplied by anything is 0. So we're substituting the value, direct substitution, as you know. Yeah, so let's do, if you have red limit, okay, x to the power n minus 1, that stays because this has no h. Yeah, so nc1 x to the power n minus 1, this is the thing. Now just do del, sorry, that's not del, that's factorial n factorial divided by, what is that, n minus 1 sorry, that's it, n minus 1 factorial. Yeah, so let's do it, and there's x to the power n minus 1. Yeah, of course. So that is n into n minus 1 factorial divided by n minus 1 factorial, so that gets cancelled, x to the power n minus 1. So as n is multiplied with that, we get the final answer as, let's write this, n x n minus 1 as the derivative of x to the power minus x to the n. Yeah, so that's how we prove this thing. Okay, if you like it, please share. Okay, if you like it, please share, and if you don't like it, just dislike the video and go on. Yeah, okay, right. Subscribe, like, share, and what we have to do is just spread mathematics all over the world. And mathematics is the love which spreads if you just enjoy the thing. So if this was helpful, please comment.